Okay guys, so now we're gonna be talking about measurements in general. So first thing, we're gonna measure the small distances. We use a meter rule as we agreed. You always, when you're using these instruments, we said we look at 90 degrees to avoid parallax error. Okay, so for short distances, we use a meter rule. Now for long distances, we said we use a measuring tape or a meter tape to measure the long distances. We said vernier caliber and micrometer screw gauge are out of the scope, but it's good to know them in general. You could give them a read. Now we're gonna talk about measuring time. We said time is measured using a stopwatch, and we talked about how to convert between the units. So we said from hours to minutes you multiply by 60, from minutes to second you multiply by 60. And then if you want to go back from seconds to minutes, you divide by 60 and so on. You want to go the bigger way, from hours to seconds, you just multiply by 3600, or you want to go from seconds to hour, you divide by 3600. So in this watch, we have 3 minutes, 53 seconds, and 1700 of a second. So if you want to calculate this, so into seconds, basically you might be asked to do this. So that would be, as we agreed, so 3 minutes, so 3 times 60, and then you would add the 53 seconds plus the 100 of a second is like saying the 17 is divided by 100. So that would give you 3 times 60 is 180 plus 53, sorry, plus 0.17. This will give you about 233.17 seconds. That's for converting time in general. So you're going to be using this in speed, motion, and all of that. Okay, and then let's go back to the idea of oscillations. Now, oscillations are a big part of the paper 6. So how to count the pendulum, basically. So if you look at this pendulum, so if we drag the pendulum back, that's the starting position, and we let it swing, that's quarter, a quarter, a quarter, and a quarter, and that is 1 oscillations, and so on. So it's really hard to count 1 oscillation, so we said we count a total number of oscillations and we get the total time, and then to get the time for 1 oscillation, we get the total time of oscillations divided by the number of oscillations. So if you look at this, for example, we're gonna go to the idea of, I'm gonna show you a real quick one. So go to Fed. All right, and then go to simulations. Bear with me. And then we're gonna go to the pendulum. Is the pendulum? Yes, that's the pendulum lab. So bear in mind, this is the pendulum, for example. So what we're gonna do, you're gonna get the stopwatch, and then you're gonna do the stopwatch, and then up count, and that's 1, and that's 2, 3, 4, 5, 6. There's 7. There's 8. There's 9. And 10. So basically in 10 oscillations, the total time was 17.46, as you could see on the left here. So we go back. So we have the total time was 17.46, and we counted 10 oscillations. So the time for 1 oscillation, small t, is going to be 1.746 seconds per 1 oscillation. Okay, so when you do this, you decrease the human error and human reaction time, because it's really hard to start the stopwatch, start the pendulum by yourself in a lab. It's not feasible. Also, when you're counting the oscillations, you don't count a lot of oscillations, you count about 20, because if you do that, you might lose count, or if you count more, the pendulum might stop. It's gonna lose its energy. Okay. Now, also, if you increase the length of the thread, the time period increases. So if you look at this, if we play the length, you see it's gonna take more time to go back and forth. You decrease it, it's gonna be quicker. Increase the length, it's gonna be slower. Decrease the length, it's gonna be quicker for 1 oscillation. Okay, which is very important. Now that's the idea of measuring time in general with length.